after we have looked at the greatest common factor and how to use this to factor polynomials, we are looking at another method. Well, basically, it's going to come down to, it's going to be the greatest common factor again. Factoring by grouping. So I just want to use this example here to illustrate that sometimes my greatest common factor can look different. It can be more than a monomial which has only one term. If you look at this example right here, then we have two terms. We have this term, this is my first term, and then I have plus this term right here. Now, in these two terms, there is something that they have in common as a factor. And the thing that they have in common is, well, which factor do they have in common? The first one says 7x times x plus 1 plus 2 times, well, x plus 1 again. So x plus 1 is a common factor in both terms. And that means it is the greatest common factor. The greatest common factor in this case is x plus 1. It is a little bit different than before in such a way that this is a binomial. It used to be a monomial before. But that doesn't really make a difference. Everything else is going to be the same. I will pull out the greatest common factor x plus 1 out of both terms, and I will get this. This is going to be the same thing as I am taking this x plus 1 and I do the opposite of what I'm doing when I use the distributive property. I pull it out. And I'm going to be left in my first term only with the 7x plus 2 in my second term. And you notice that I can go backwards again. I always have to be able to go backwards. I can multiply this out. I can say, what is x plus 1 times 7x? X plus 1 times 7x. X plus 1 times 2. Plus x plus 1 times 2. Well, multiplication can be reversed. This is the same thing what we have started with. All right. Now, let's have a look at if we are not in such a perfect world as in the last example, but with an example like this. This is a polynomial, and we are supposed to factor this by grouping. First, notice there is no GCF. There is no common factor between all of these terms whatsoever. 3, 6, 4, and 8 do not have a common factor. And the last one doesn't even have an x, so there is nothing really that I can do if I wanted to factor it directly. Now here's the thing. If I want to factor something that has exactly 4 terms, I can do the following. I can pretend that these are 2 problems. And I am writing them down as such. I am only looking at 3x squared plus 6x. This will be my first problem. And back here, 4x plus 8. I am grouping that into 2 problems. Now, the first one right here, 3x squared plus 6x, that we can factor because there is a greatest common factor in those 2. And the greatest common factor here is 3x. If I pull out the 3x out of my first term, I'm just going to be left with an x. And if I pull out the 3x out of my second term, let's have a look. 6x divided by 3x, that would be just 2. So I am just doing the first one. Now I'm looking at the second problem here, positive 4x plus 8. Greatest common factor between these two is, let's see, that would be a positive 4. And if I pull out the 4 out of my first term, I'm left with the x. And if I pull out the 4 out of my second term, I'm left with the 2. And if I now step backwards and I look at my problem, then I have something just like before. I have a factor of x plus 2 in my first term, and I have a factor of x plus 2 in my second term. So this factor of x plus 2 now is a common factor between both terms, and it can be pulled out again. I can pull out the x plus 2 out of my first term. I'm left with the 3x, and I pull out the x plus 2 out of my second term, and I'm left with the positive 4. So the thing here is this. If I start with something like this, and I have 4 terms, then I will be using factoring by grouping, by pretending that this is one problem and this is a second problem. And I will factor each of those ones separately, just like this, just to find that there is a common factor in both of these terms. And in this case, the factor that we have found was x plus 2 on the left, x plus 2 on the right. I can factor this out, and I am done. So really, I have to factor twice when I have 4 terms. One thing to mention right here. A typical thing to get this confused with is to see the following. Up here, the 6x and the 4x, these two terms could have been combined into, well, what is 6x plus 4x? That is 10x. So if I would have done this at first, then I would have made my problem worse. If I still want to factor this, then I cannot directly factor this now. We have to leave it as this, and then looking at it as if there are 2 problems, factor both of these separately. Let's do one more example of these. I want to factor x cubed plus 5x squared plus 2x plus 10. Now, greatest common factor? No. There is nothing that all of these terms have in common. How many terms? Well, there are 4 terms. 4 terms means I'm going to be trying grouping. So in other words, I'm going to pretend this is one group, this is the second group, and I'm just going to factor these ones separately. So if I look at my first group, x cubed plus 5x squared, then they do have something in common. They have a common factor of x squared, which I then can pull out of these each terms. X cubed, take x squared out, you're left with x to the first. 5x squared, take the x squared out, and you're left with the 5. Now, observe what happens if I look at the second group, 2x plus 10. Both of these have a common factor of 2, and I will factor that one out. 2x, take the 2 out, you're left with the x. 10, take the 2 out as a factor, you're left with a 5. And now this is almost like magic. What you have just found is a common factor in both terms. So maybe let's do it like this. I had 4 terms to begin with. I turned it into 2 terms, and now I can directly factor. The common factor was x plus 5. It is going to be pulled out of the first term, and I'm left with an x squared. and I pull it out of my second term, and I'm left with a positive 2. So, one more time. 4 terms, no GCF, but you have 4 terms. We are going to be using factoring by grouping. We are pretending we have 2 groups, and we turn it into 2 terms. If we found a common factor, then we are just proceeding as before.